Hey there! In this video we are going to look at writing sine and cosine equations for functions if all we're given about those functions is information about their maximums, minimums, where they occur, and so on. Alright, so here we have some information about a sinusoidal function. This time we're looking for a cosine function, and we have a maximum, and then we have the nearest maximum as you move to the right. And so we're going to try and write an equation for that. In this form here, we just need to work out the values of a, b, c, and d, our parameters in our equation that specify our amplitude, period, phase shift, and vertical displacement. It probably helps to draw a simple sketch of this to help visualize it as you're coming up with an equation. So not that we necessarily need a grid or anything, but since both of these are on the positive side, I'm going to do about like that. We're going to say that we know that at 4, it's at 16. And when we are at 36 over here, so this is not really to scale along my axes, it's there again. So I know it's here and it's here again, 2 maximum points. Now you're given the minimum value. You're not told where it is, but it has to be halfway in between those two. So if you can kind of look and just think about what halfway is, you can locate that point down there. And it says it's -10. If you want to figure out what value that is, you can add those and divide by 2. Find the average, right? So 40 divided by 2 is 20. So that minimum, if you want to know, is at 20. Not that we necessarily need to know that to write the equation. So we're first going to look at what the period is, because we have to work out our 4 things. The period we can work out by just looking at these 2 maximums. The distance in between there is going to be the period, right? Because the curve is going to look something like this, down to there, back up to here, and so on, right? That's what the curve more or less looks like. So you have one cycle of the curve between those maximums. So this distance is 36 minus 4, or 32. So if the period is 32, the b value is going to be 2 pi over 32. You can reduce it to pi over 16 if you want, but I'm going to leave it like that. The second thing we need to know here is, let's look at our amplitude next. Amplitude. To find our amplitude, we need half of the distance between those two, right? Because it's the middle to the top or the middle to the bottom. So half the distance between those two is what we're looking for. So if we say it's 16 minus -10, right? That's going to be the difference in between those two things, divided by 2, half the difference. So 16 minus -10, 16 plus 10, 26 over 2 is 13. Our amplitude is 13. While we're thinking about the vertical things, let's think about the vertical displacement. Vertical displacement. The vertical displacement is going to be halfway between these, or in other words, the average, just like we talked about halfway between the 36 and the 4. So if we add those 2 numbers and divide by 2, it'll give us our center line, and we can use that in our equation. So if we say 16 plus -10, divide by 2, 16 plus -10 is 6 over 2 is 3. So we have our vertical displacement of 3. So at 3 here, we have our center line. And then the last thing we need here is our phase shift. Now that's going to depend on kind of where we pick as thinking about the starting point. It makes sense if you have a maximum and you're writing a cosine equation to just use that value, because cosine starts at the top of a cycle. So I'm going to use this 4 to the right here, imagining that the curve is shifted 4 to the right. So phase shift we can say is 4 right. You could imagine that it's 36 to the right as well, right? If you wanted to use that point, but it makes sense to use the closest one. If you really wanted to, you could use this one as long as you called it a negative cosine curve, but we won't do that because that's only useful if it means eliminating the phase shift altogether. So I'm going to go with that 4 to the right. So if we're writing the equation for this, our equation is going to look like y equals 13 cos 2 pi over 32, our phase shift of 4 to the right minus 4, and then plus 3 vertical displacement. So that is an equation for that curve that meets those criteria. All right, we're going to do one more here. All right, so here we have a sine function, and we're given two pieces of information. We're given a maximum at this point, but instead this time we're given a minimum, the nearest minimum to the right of this point. So again, I think a rough sketch helps here quite a bit. So since both of those x values are positive, we don't need the graph on that side to try and do this. So we know that at 2/5 we're up at 12 here. Again, this is just going to be a rough sketch. And we know that at 8/5, 8 pi over 5, let's extend that a little bit, we're down here at negative 28. So we know we're down here. So we know the curve looks like something like this. We can work out some other values as well if we need them, but for now we're going to use those two. Now, we still need to find our 4 parameters again. So maybe let's do the vertical stuff first this time. We'll do the amplitude. The amplitude, half the difference between those, 12 minus negative 28, or the distance in between there, divided by 2. So 40 divided by 2 gives us 20. We'll do the vertical displacement. Vertical displacement, similar formula, similar method, except it's the average, so it's 12 plus negative 28 divided by 2. So that's going to give us 16. Negative 16 divided by 2 is negative 8, so the shift is 8 down. We need our period as well here. Now the thing to realize here is the two values that we have here don't represent one complete cycle, they represent half a cycle. In between here is half a cycle. So like this part here represents half a cycle. For a whole cycle, we need to either go up to here, or we need to go back to here, or since it's a sine curve starts in the middle on the way up. So I'm going to think about it like that, potentially as one full cycle. Any way we think about it, we have to realize that the difference between these two values is half the period. So if we're going to work out the period, we have half period is the difference between those two things. So 8 pi over 5 minus 2 pi over 5, or in other words, 6 pi over 5. If half the period is 6 pi over 5, the period has to be double that. It's 12 pi over 5. If our period is 12 pi over 5, our b value might be not a nice whole number here. The b value you can get by, again, saying it's 2 pi over the period. It'll work even if we have a fractional period to put in there. If we say 2 pi divided by 12 pi over 5, we can still work that out. 2 pi divided by 12 pi over 5 is like 2 pi times the reciprocal 5 over 12 pi. If we cancel this, we get 6. So the b value is 5, 6. I'll write it right there. And then the only other thing we have to do is think about the phase shift here. Now, we're given a maximum and a minimum. So sine doesn't start at a maximum or a minimum, it starts at a middle point. So we could use this middle point, except that's a middle point on the way down, so we would have to call it negative sine. If we were going to call it that, so let's write that equation as assuming we're using that, we need to know halfway in between those two. Halfway in between those two, if you have 8 pi over 5 and 2 pi over 5, halfway between 8 and 2, again, you can add them, divide by 2, find the average. 8 and 2 is 10, divided by 2 is 5. So that halfway point is going to be 5 pi over 5, or just pi. So if we were writing an equation using negative sine, negative 20 sine, we need our b value of 5/6. If we were using that phase shift x minus pi, and then we would have our vertical displacement of -8. So that's an equation if we're writing negative sine, because that's probably the easiest point to find here. If you wanted to find a positive sine curve, you can either go this way or you can go this way. I'm going to choose to do the first of those two things. So we already saw that this was 5 pi over 5, and we have 8 pi over 5. So we got 8, 5, 2. The difference between each of those is 3 pi over 5. So if I go another 3 pi over 5 this way, I'll be a little bit to the left. This is actually going to be minus pi over 5, 1 pi over 5 over there. A quarter of that period. The period is 12 pi over 5, so I got to go back a quarter of a period to get to that middle point. Now I didn't draw it very well. It's probably a little up higher. That doesn't look very good, but we have the right idea here. So we would have almost everything else the same here. Of course, this would be plus 20, no negative sign there. Sine, the same 5/6 as our b value, but this time our phase shift would be to the left by pi over 5, so we'd have plus pi over 5 there, and then we'd have our -8 here. So that's an equation if you're using positive sine. We could have actually also used this point over here. If we had thought of it as shifted there, we would have to add another quarter of a period on there, like a quarter of that value again, so 3 pi over 5. So if we add on 3 pi over 5 to 8 pi over 5, we would have 11 pi over 5. So we could also have negative 11 pi over 5 with that second one instead if we wanted. But that being the closest one to the starting point, we'll use that. All right, so that's writing equations for trig functions, sine and cosine, that involve multiple transformations where all you've been given about those functions is information.